Hello everyone, my name is Ashwin. Today I'm going to show you a JavaScript library called Redux. Now, Redux is a predictable state container for JavaScript applications. So what is a predictable state container? Every JavaScript application has a place to store the data needed for the application uh, called state. And the entire application is driven by what is in the state. Now, Redux is most popular in React applications, but it is not restricted to React applications. Redux could be used with any framework. It could be used with React, Vue, Angular, perhaps even vanilla JavaScript applications. But now I'm going to introduce you to Redux through React because when you talk about state and state management, React comes to my mind. So here we have a simple React application which has a state, which has one word, hello world, and we have three buttons which will transform the hello world into different casing. For example, if we were to click the uppercase button, it will transform the text into uppercase, and lowercase transform to lowercase, capitalizes each word in the state. Okay, so let's talk about state management. What do we exactly mean by managing state? So it is this part of the application that we are concerned with. This is where the stateful logic gets executed. So this I would consider the UI part of React, and this is the logic behind the UI. So we have two sections in this app. One of them is the rendering, and the other one is the state. So we're going to refactor the stateful logic in such a way that let's group all this logic in one place, and we'll talk about state management as we go on. So let's start by combining all these three methods. Right now, we have three different methods attached to three buttons, which will transform the word in the state. Let's start by grouping these three functions into a single function. Now, how would we go about that? Let's create one function. It's called change casing. And in here, we'll try to change the word. But what kind of change can we make? It could be uppercase, lowercase, or capitalize. How will we know which case it is? For that, we may take an argument. We'll call this argument the type. We'll say, what type of change do you want? If type is equal to uppercase, then we will set the word to be uppercase. I'm going to move it here and say else if type equals lowercase. In that case, we will transform the word into lowercase. Else if type is capitalized, we will then capitalize the word using this string.replace function. Okay. And we could, since there are only three cases, we could say if, else if. In the last clause, we don't have to specify this function. We could simply say else. But this is a good practice to always check before, if the type is capitalized, before you do something to the state. In future, there was a different input other than uppercase, lowercase, or capitalize. We don't want that to fall back to capitalize. So if the type is none of these three things, we will leave the state untouched. So I'm going to make a corresponding change. We no longer need these methods, and on these buttons, let's make let's change these functions to actually change word, and the type is going to be uppercase, change to lowercase, and if you click this button, it should be capitalized. Let's make sure we broke nothing. Oh, is this dot change word? Oh, it is change casing. Nice, that works. So what have we done? We have managed to group the all the methods under one roof. So now it is in one place instead of having it in 3 different places. Although everything was inside the class, this is another way to do the same thing. Okay, let's go one step further and try to combine both the place where we store the state and where we modify into one. Let's group them together. Unfortunately, we cannot do this within the React class because we need to have the state only have objects. We can't have functions inside here. So what I'm going to do is remove all of the state from the React component and manage the state from outside. This is perfectly valid. There's nothing wrong with it. We could bring the state out of the React component and have it as a global variable, and then pass the state as prop to the app function component. Sorry. So let's do that. We'll remove all of this logic from the app and move it down to the global space. Of course, we need a variable declaration. And so how do we combine these things? We should probably put both of this in one object, and that object will hold the state and as well as the methods to modify the state. So let's do that. Another good use for an advantage of having the state outside from the app component is that the state no longer is tied to one component. It lives above everything else. So that means we could pass the state and its logic, which are coupled together, through to any component we need, not just app. We could, in future, we might have several other components. So that is another advantage of moving the state outside of the React context. So what we can do is we'll move this function inside this object so that we store both of them in one place. So I'm going to move this change casing function to inside the object so that we have everything in one place. Okay, and we don't need this. And it appears to have syntax error. Okay, so as when you save it, this is obviously going to result in an error because we no longer have a state inside the app, and this is going to return null, and that will result in an error. So, and we need to make a few changes in this object, right? So, first off, we can no longer call it a state because it's not state. It also has a logic that will manipulate the state. So actually, the state is just this these two words. The string is the state here. So I'm just going to rename this as the state, and this is, let's call this store, which is kind of like a place to store both the state and its logic together. Call it store, and what we can do is here we will pass the state to, and And of course, before we move away, this is no longer this.state.word to uppercase. There's no this.setState function because that method is a part of the React component class. And since we're outside, we no longer have this. Instead, what we can do is like just set this.state to equal the uppercase. So anytime we make a change, we just grab the state and change the state to something else. So I'm going to go ahead and make the same change across all the other methods. And once more here. Okay, so this is fine. And if you've been dealing with JavaScript for some time, might notice we're relying on this keyword here. That means these methods will only work as long as you call them like store.change casing, because we need this to point to the state on the store. So we need to always make sure it is being called with the store at the front. So that means we cannot just pass this function to the button, because if you pass just this function out to the button, when this button calls the function, this value will not be bound to the store object. Now we could do something like bind this function to the store and not worry about this at all, because this will bind this keyword to this object. Or we could completely get rid of stop relying on this keyword. Now how can we have a state attached to in the same place but get rid of this keyword? We cannot simply say state equals state.word. As you can see already, my editor is pointing out that there's nothing called state, because the state is not a global variable somewhere. It is inside this object. Now what we can do is have the state in closure scope. So we can have this entire store object. Instead of having global variable, we can capture the state in a closure. Now, how will we go about doing that? The moment I say closure, you must be imagining immediately functions. So instead of having a store like this, let's create a function that will create a variable and will create this return this object to us, and this object will capture the state in the function in closure. What do I mean? Let me show you. We'll create a function called createStore. It's a function. Here we will have the state as a normal local variable, so this is not living in the global scope. We'll set it to hello world, and let's return the store object. Here we'll move the change casing function to here. Now since we're having access to the state and it's no longer in the global scope, because we just create a function to prevent the state from leaking to the global store, now we will be able to get rid of this. And by getting rid of this, we no longer have to worry about binding this keyword to anything at all. So this is going to work just like that. So we can return the store, and instead of creating the object ourselves, we will just call the create store function. This is going to return the store here, and this will return particular object, and the store is going to have this change casing method, but we don't no longer have access to this state because it is inside this function scope. We cannot access state, and neither is it on this object. So let's go ahead and do just that. we will just set state equal to state so that we expose the state to the store so that we can access it. Okay, now we can say word is equal to, we'll pass this store object here, say word is equal to store.state, and change casing function is just store.change casing. Okay, let's give that a save. Oops, seems to be an error. Let me give this a refresh. I'm not exactly seeing the error here. Unexpected token 5590. I think I may have missed. Yeah, I'm missing a curly brace here. Okay, that took a while. Sorry about that. All right, so let's go back to defining the word. Say store.state, and change casing function is going to be store.change casing. And again, we're again referring to the state here. It's no longer in state. This is coming from props, and these methods are again coming from props. So that should work. Let's make sure it works. Ooh, state.word to uppercase is undefined. Why is that? Because we don't, our state is just like a normal string. It is not an object, so we should probably get rid of this word. See, change the case, nothing happens. Now, why is that? Is it like we seem to have missed something? Why is the thing not changing? Let's make sure that it is actually changing the store. Then we'll figure out why it does not change in the actual app. So let's go to the console. Since we have exposed the store in the global scope, we should be able to type store. Let's try the Chrome console. Okay. We're not able to access the store. Oh, right. So this, we'll just expose the store to the window object so that we can actually access the store. Now let's be able to access the store. Yes. Now the state says hello world, and let's try changing it and then take a look at the store again. It still says hello world, but didn't we just clearly change it here? We are explicitly setting the state to state uppercase. Maybe this function is not being called. Let's check if this is actually being called. We'll just console log the type to see if this function is getting triggered or not. It does get triggered, but unfortunately, the store is no longer keeping track of the change. Why is that? Now, this has to do with something peculiar with strings, because the string is immutable. What does that mean? So every time you make a change to the string, you're not actually altering the string. You're actually creating an entirely new string and replacing it with a completely, replacing the old string with a new string. So what does that mean? So let's say, for example, We'll open the Chrome console for this. For let's sample, for example, let's say we have a string which is like hello here. And if we create another string, like let's create a copy of the string, call it string2, and say, we'll set it to equal string1. Right? Now string2 is also going to say hello as does string1. Now if we change string1 to something else, the string2 doesn't change. Now this is because not only does string2 receive a copy, it's not actually receiving a copy of string1. What it is receiving is this string lives somewhere in your computer memory, and the variable string holds the address to this particular string. And when you assign one variable to the value of the string, it receives a copy of the address this string is pointing to. So there's this string somewhere, you can imagine, in your computer, in a box. There's this string hello, and the address of that spot is held in the string. And when you assign string2, you're actually setting the address equal to that. So this string2 is pointing to the hello string. And when you actually set string equals by, what is actually happening is an entirely new location in your computer memory. The string by gets created, and that the new address, this string is set to the new address. But the string2 is still pointing to the old address. So this is why when you evaluate string, it is pointing to the word by, but when you evaluate string2, it is pointing to hello. Still, it's pointing to hello. So how can we keep this string2 updated with string1? It is impossible unless we do the same thing. We keep on doing this string2 equals string every time we make a change to string. But there's another way to dynamically fetch, give everyone a copy of the string and keep it updated with that. What is that method? So instead of having a variable like string2 pointing to string1, we can have a function that will return string1. That way, we're not making any extra variables or taking a copy of the string, but just returning the wherever the string is pointing to every time the function is called. So we can do something like get string, a function that will always return this string. So it works by calling this get string function, just by. Now if I change the string to changed, something like that, and then call get string, it is going to reflect the change. So now this function could be like you can make several copies of this function and give it to several places, and every time this function is called, it will be made sure that always the value is updated with this string. So let's use that particular trick. Instead of passing the state as a copy, let's pass the state as a function. Let's say get state, and it was just a function that will return the state variable. Okay, now this is going to change things here. We no longer have store.state. We could say store.getState. Call the function actually, so it returns the word and the word goes there. Hopefully this should fix the error we were having. So let's try this again. Let's try uppercasing. Still doesn't work. Let's check the console. Nothing happens. We'll check the store again. We can't see the state because state is no longer here, but we do have the set state function. Let's try store.getState. It says hello world, probably because I capitalized at last. Yes. Let's try uppercasing it and then call set state again. There we go. Now let's try lowercasing it, call set state again, results in hello world. So our methods do work. We haven't broken anything yet, but we do have a problem. There's no change in the actual React state. Now, why is that? So here's another difference between having a state inside the React application versus outside the React application. So when we have a state inside the React application, any changes to the state, React will be able to track it. And it will trigger this render function once again whenever something changes in the state. Now, this is why you actually see something different on the screen every time you change state. Because if you remember, state is just an object or some place to store variable. Just changing the state will not actually make the DOM manipulation. It is the React component which actually does the DOM manipulation. So having the state inside will let React keep track of the state, and whenever the state changes, it will re-render the entire application, changing what's on the screen. So how can we do that from outside? Inside we had this set state function which was triggering the render for us. Now how can we do it from the outside? Can we just like call app.render? The answer is no, because app is not an object, it is a class. And only an instance of the app can call the render function. And even when you call the render function, it is just going to return this entire HTML. That still does not modify the DOM. The thing that actually modifies the DOM manipulation, is the React DOM library. So aptly named, React DOM library is the one that is responsible for changing things on the DOM. So how do we actually render this application? The answer is right here. This is how you render the application. Watch what happens if I remove this line and run it. We don't see anything on the screen. It is actually this line that you have. Almost you never write it by yourself. It is always coming with a boilerplate. It is this line that is actually painting the whole screen. So if we want to change something and repaint the entire scene, what we can do is like call this function after we made changes. Now, how do we know when these changes occur? Like, do we just set an interval to keep updating like every 10 seconds? That doesn't sound really plausible, is it? What we can do is like we know when the state will change, because remember the first step we did was to capture all the logic under one roof, under one function. So if anything is going to change the state at all, it is going to happen from this particular function. So that means any kind of action that we want to do after we change something in the state can be done like at the end of this function or anywhere within this function after we change. So at the end of this function, let's add this React DOM render function inside here. Okay, give that a save. Now let's run the functions. There we go. We are changing the state and the state actually changes, and by re-rendering, we're able to manage the state from outside. So it is perfectly okay to bring the state outside the React application and manage like this. Is this better than having the state in the app? That question is up to, it depends on the person who's building the app. So here we're just like having the state outside and managing it outside, and therefore it can be done this way. Now everything works. This store pattern is a great thing. So what does anything have to do with Redux? We'll get to that part in a moment, but before we do that, let's make a few changes to refactor our solution. First off, we are grabbing the state through an argument. Let's instead of taking it as a normal parameter, let's take it as a named parameter. What does that mean? Which means we're no longer going to receive the argument as a string, but inside an object with a property in it, and inside the property the string would be there. So conversely, this type is just going to be unpacked from a object. So what this allows us to do is, instead of passing a string, we can pass an object with type and property. We could do similar thing here. I'm just going to go ahead and do this for, and here you can again say, oops, type. Cool. Now let's make sure we broke nothing. Give this a save, and everything works. Good. That's awesome. So that's one tiny improvement. Instead of we now know what we are passing. Previously, we just were passing the string, but we did not know what the string was for. Now we know we are actually passing the type. These are named parameters now. Okay. Let's make another change. This React logic, we're still having some React logic inside the store, and this is not really reusable. You said, like I told you, one of the advantages of having a store outside is that we can pass the store to any component we want, but that is not going to work if you're going to call React DOM render app here, because this is going to only work when app is the one that is dealing with the state. So this doesn't seem really reusable. So what we're going to do is, like, instead of calling this render function, we will take some generic callback function, and we'll let the user pass a callback function to our to our store. So from here, we will only receive the callback function. So we can do that by making another method in the returned object, the store object. Let's create a method called subscribe. So this will allow you to subscribe for changes. Anytime something changes, we will call the subscribe function, which will call, we will call the callback function, which will notify the changes to whatever function we receive as a callback. So subscribe will take a function as an argument, and we're going to capture that function. Let's say we have the function and callback. We'll initially set it to null, and when someone chooses to subscribe to changes in the state, we will set the callback to be equal to function. So now the way it works is that you'll be able to do a store.subscribe and give it a function, and this function will trigger every time something that changes in the state. So now we're no longer referring to app or React DOM or anything within the store. So the way you can actually use this thing is by saying store.subscribe and give it a function. So this function should re-render the application anytime the state changes. So the difference between the way we had it earlier, having the React DOM render inside versus the outside, is that now you get to control what happens when the state changes from the outside without relying too much on this create store function. Okay, so let's make sure it works. And it works. We haven't broken anything. We just remove this logic outside here. Now, what if I wanted to do multiple things on when the state changes? Perhaps I want to, I don't want to manually call store.getState on the console every time the state changes. I want the console to keep track of the state, so that maybe it's helpful while debugging to actually look at the state once in a while. So we can add the logic like here. We can perfectly say console log store.getState, but our store should have the feature to be able to pass multiple functions and handle multiple functions and call the callback function every particular callback function. Sort of like your add event listeners in DOM, where you can keep adding multiple event listeners on a button, and when you click the button, all of your functions fire. How can we do that? We can easily do that by making this callback as callbacks into an array, and every time someone subscribes to the store, we will just put that function at the end of the array. Right. So that is one way of having multiple functions fire. Sorry about that. And here we cannot just call the callback function, because it is no longer a function, it's an array. What we can do is loop over the callback function for each function. We will just call the function. This ensures that every function gets called. In our case, we're just passing one function which will be pushed into this array, and every time something changes, we can call the function. So let's now make sure that it still works. It works, no problem at all. And let's also test our new feature where we're able to subscribe to with two different functions, and both functions should fire. So we'll just console log store.getState. Open the console, we change. Nice. So we have a way to subscribe to with multiple functions. So this is just like a new super addition. So what other changes can we make to the store? For having the state set to hello world, and what if we wanted to start with a different string? We don't want to start with hello world. We wanted to start a different string. And what if we can generalize the store behavior? What if we would just want it to be an object here, and within the object we wanted a hello world. We want this to be dynamic. And because this is going to be dynamic, we also want this logic to be dynamic. So that this create store function becomes highly reusable. So we can do that. We can just instead of having the logic hard-coded here, we can receive the logic through another function. So we can let the user define another function, what they want to do to the state, and we will just call the function here. We have to make a few changes to how it's going to work. But let's start, and we'll also receive the initial state as argument here. So we'll receive one function from the user, and we'll also receive the initial state. We'll call it preloaded state. Okay, and nothing is going to happen yet, and we're going to move this logic to a separate function. We will move this logic to, let's say, can have it anywhere. Just going to put here change casing, and move all of this logic inside here. A lot of squiggly arrows. What does it mean? What is type? We no longer have access to type or state. Seems to be a problem. Let's say we can just receive it as an argument. We can receive the state as argument. That will remove all of this errors. And type, again, second argument, we'll receive an object called type. Okay, and we'll let the store pass us this state and type to us. This will take care of the communication downwards from the state. So we can call the function like state, and we will pass this object, whatever we're having here. Let's call this action, what you're intending to do, and we'll pass this function down to the state. Okay, the state goes down, but if you recall what we discussed earlier, just by changing the state here inside the function is not going to guarantee that this state will change, because this is going to be a copy of this, and you're only making changes to a copy. So we actually need to know the new value of this state so that we can change the actual state, which is on line 38. So instead of assigning here, what we can do is return the new value of state from this function, and whatever being returned from here, we will capture it in the state so that we're actually making changes to the state. Remember, the only place we can make changes to the state is here, because this variable is unique, and you can only ever create copies of the address here, but you cannot actually keep track of the variable. You cannot change the variable anywhere else outside. So this is the only place we could do it. So we're going to return the object from here and pass it here. And of course, we need to set the initial state, we will no longer hard code it. We will say preloaded state. State will be equal to preloaded state. If nothing is passed, it will be undefined, which is totally fine. So here, okay. So when we create store, we actually need to pass this function as the first argument, and the preloaded state we will say hello world. Okay. And this is going to set the state. We just managed to move things outside, change things a bit. We actually have not made any changes to the logic itself. So if everything went well, this should still work as intended, and it does, because all we did was just remove the logic outside. And now this is like completely reusable. You can have any kind of state here, and you can have any function here. So state, you can think of it as this is the thing I want to keep track of, and this is how you should trigger changes. And let's make it completely reusable. Instead of calling it change casing, which is like very specific to manipulating strings, and our state could be an array or an object or anything, we'll give this a generic name called dispatch. We'll see in a moment why I'm giving these specific names, but for having dispatch, change casing, everything, let's make sure it works. Oh, it's not working anymore, because remember in this change casing we're saying store.change casing. We just changed the name. We'll change it to dispatch again, and again here change. Okay, let's see, make sure it works. Still nothing has changed right from our React application where we have the state. Now being outside, there's nothing actually that is changing. And we'll do one tiny change. What happens if we do not provide a preloaded state? What happens is, like, first of all, this is not going to display because their state is going to be undefined. Another error we're going to get is, like, when you try to change the uppercase, it's going to result in an error because state.uppercase is not a function, because state is not a string at all. So changing it to uppercase is not going to work. Undefined dot to uppercase is not going to work. So what can we do? So the state might have a word or it might have undefined. So what we can do is, like, we can actually check if this is a string in the first place. If it is not a string, don't do this. So we can say if state is not defined, if not state, which means it is undefined, we will just, like, not do anything at all. We will just return. Or we could just say if nothing is specified in state, we will say state is going to be equal to hello world. If there is a state, like if this was created with the preloaded state, we'll just leave it. But if it was not created with the preloaded state, this is how we will protect ourselves from this kind of error. So this works. Let's see if this works. Yeah, now this works. So it sees it's undefined. It's going to quickly say we will set the word to hello world and make the changes from there. There in ES6, there's a shorthand for doing this kind of check. It's called default parameters. Essentially, what we can do is, like, we can say state equals hello world, and comment this out here. It's just you're going to see that it works in the exact same way. So these are called default arguments, meaning if this argument was undefined, JavaScript will automatically bind this string as the state. So that's what this means. You can learn more about default arguments in MDN. So we have an entirely working library in our, this is a mini function that you can use anywhere we want. And again, you can create any kind of store. We can create multiple stores, and we can pass the store to any component you want, not just the app component, which is a really neat thing to be able to transport just the state and its logic without having to transport all of the DOM elements. Okay, we're pretty much done here. So what you saw was Redux. This is somewhat how Redux works. And to prove that this is how Redux works, I'm just going to first add Redux as a dependency, and we'll add Redux as a dependency to this project. It's going to reload. Let's put this back preloaded state because we want the state to render the first try. So we will say hello world is our string. Make sure everything works nice. So what is Redux? Redux is a way to create stores which will have these functions: get, state, dispatch, and subscribe, to allow you to manage any kind of state. It could be a string or object or array or anything. Just what we did, that is exactly what Redux is all about: being able to manage the state from outside and being able to pass it to any component that requires the state or the logic. So one of the several Redux library basically makes a lot of named exports. It exposes some useful functions, and one of the useful function is a create store function. So we're going to we already have a create store function, but let's try using Redux's create store function and see what kind of features it brings us. So create store is actually a named export. It's create store from Redux, but unfortunately we cannot yet do this because we have a const create store, and if we import again another create store, it's going to cause a name clash, and const variables could not be declared. We can comment this out so that we use the create store from Redux, and let's give it a save and see if this is going to break our application. And it works just like how we intended it to work. So our create store function is exactly how Redux's create store function works. So this is a small implementation of Redux. Of course, Redux has much more power. It has other features. It has a middleware feature and binding feature, a compose feature, and there's a lot of features inside Redux. But to give you a basic idea how Redux works, I prepared this video. I will drop the link to this code sandbox in the video description. Feel free to give comments or feedback in the video, and thank you for joining. Goodbye.